Objects. This is part 1 in a 2-part series about JavaScript objects. In this part, I'm going to talk about the basics and definitions of how you create and manipulate objects. But also, I'm getting into more complicated stuff like mutability, referencing, copying, and comparing objects. As always, this presentation is an active presentation, so make sure that you have your exercises folder handy and that you have committed everything to Git so you're clean and ready to go. Basic object handling is described in chapter 4.1 of javascript.info. So if you go there and scroll down, 4.1 is objects. In this presentation, I'm also going to use 4.2, not reference it directly, but that contains the theory that I'm going through. So, basics. An object is a group of properties, each with its own value. Here we have an example of an object called object, really bad name by the way, and it has 3 properties. And each property has a value, like property, value. These properties can be in quotes, but they don't have to. You could write it like here, first name in quotes, or like here, first name without quotes. The first type is used in JSON files, and it must be in quotes. In JavaScript files, you can decide if you want quotes or not. Of course, you have to use quotes around strings in the values. Each property is basically a variable inside the object and can be of any type. It can be, we have here a string, a number, a boolean, and it could even be another object. So the difference between objects and arrays are a bit hard to see at first because both of them can hold a number of values, say different values in one variable. But arrays are intended for lists of items of the same type, meaning you have a list of strings or a list of numbers or a list of objects where each object would be similar. More on that in the next presentation. Objects, on the other hand, are intended for properties that belong together. Like in our previous example here, we have a name, an age, and a student state. And these are not of the same type, but they belong together. They describe one person. So items in an array are always in a specific order and can be addressed by a number. You can have the first with number 0 and then 1, 2, 3, 4 and so forth. Whereas properties in an object, they're in random order and are usually addressed by name. When I say random order, it means you cannot know that the first one is the name and the second is the age, for instance. And of course, to add to the confusion in JavaScript, arrays are a special kind of object. And a lot of the way you access properties are going to mix. But just remember, one object is one item and an array is a list of items. So these properties, they can be addressed or accessed with dot notation, like this example here, where we console log our previous object, we console log the first name and the age. So we have the name of the object variable first, then a dot, and then the name of the property. This is extremely simple and very nice. We can read a property, like here, we say object.firstname, so we read the first name property and set another variable to be equal to it. So we kind of read this property into that variable. It's nice to think of the equal sign as an arrow pointing that direction. It takes whatever is here and puts it in there. We can also write objects where we say object first name is set to new name. This is setting the new name into the first name property. So again, the equal sign, kind of an arrow pointing that way. If an object doesn't have a property, then we can add it. And this is one thing that I want you to try. I'll just explain it, then you can try it, and I'll wait while you do. All the things that you need to try have a try it green button or logo down here. So create an object, person1, that has first name, age, and student properties. Console log that person's last name. Here, but it doesn't have a last name. Then set the last name to Lynn, and then console log it again. I want you to see what happens on each of these console log lines. Will they console log the same, or will they console log different? And also, how can we view the entire object, all the properties? So go into Visual Studio Code, create a file called object.html and object.js, and test out this code. I'll wait. So welcome back. You've entered this code into your editor and run it on the live server and gotten some results, I guess. And if I take a look here at my code, on line 9 I console log the last name, but it doesn't yet exist. Then I set it to a value, console log it again on line 13, and then I can see here in my output that on line 9 I get an, I'll just make it a bit closer so you can see this is line 9, I get undefined. And then when I console log the same thing again on line 13, I get Lynn. So by just setting and previously unreferenced, undeclared property, by just setting it to a value, then it's suddenly part of the object. So we can add properties on the fly like this. We can also, when in the console, if we want to see the person1 object, we can simply just write the name of the object here. It says object, and there's a small triangle, and we can click that, and then we can see all the properties. And it has the last name property that it didn't have earlier. And maybe I can even do it like this. Try and console log the entire person1 here, and do it again here. See what that does. So on the first one, I have the object with just first name, age, and student. And on the second console log, I have first name, age, student, and last name. But look at this. If I open it, then it has age, first name, last name, and student. So the problem with this console logging objects is that all the properties are not actually read before you click it. So when you click it, you will always see the latest version of the object. So even though it didn't have a last name at the time you did this console log, at the time you click it and open, it will have. So this causes some confusion when you want to test your code if there is a property, because maybe you get an error that, oh, that was undefined, and then you click it and say, nope, but it's there. So be aware of that. See if you can see them here, or simply console log the object properties directly. Good. That was adding properties. How about deleting them or removing them? Well, I want you to try this also. Simply add person1 first name. Now last name is undefined. That should set it to undefined. So it's no longer defined. And then say, does it still have a property named last name? And also, does it have a property named middle name? No, it doesn't. I can give you that hint. So what would be the difference between these two console logs if you console log the last name and console log the middle name? Middle name has not been created and last name has been set to undefined. Try this out. You just need to add these 3 lines to your existing code at the bottom. See what happens and then come back. I'll wait. Welcome back again. So you have entered this code and tried it and probably have the result that each of the lines, line 19 and line 20, that is console logging the last name and the middle name, and both of them return undefined. So it looks like the object doesn't have a last name or middle name, but if we type it here, person1, take a look at it, it has last name, but last name is undefined. So it does have this property, it is just set to undefined. And that is, as we discussed with variables, the very weird thing about the undefined type, that you can set something to undefined and really confuse everyone, because then it exists but it's undefined. It's really bad practice to do this. So maybe there is a way to really remove the property. Let's try the second way. Try this one. Actually adding this line, delete, and then the object name and the property name. And this is just one line of JavaScript. Delete is also a JavaScript keyword. You can type this, you can write this as part of your program or in the console, and then see what happens when you console log last name after this, and what happens when you view the entire object. And then finally try to argue with yourself, at least, what's the difference between deleting and setting something to undefined. So try that, and once again I'll wait for you to finish. So you tried this and added the delete person last name and also console logged it. And if you have the same result as me here in line 24, when I console log the last name, I get an undefined. Just the same as before. No different at all. But if I take a look at the object, now person1, it doesn't have the last name property. It no longer, like before where it had the property that was undefined, now it's gone, completely gone, like it was never there. So the difference between deleting and setting to undefined is deleting removes the property completely, so you can never see that it was once part of the object, whereas setting it to undefined sets it to the value of undefined, just like setting it to a string or null or anything else. And then you can argue with yourself, well, what do you prefer? And I can admit, I have never ever used this. I only ever use it when I show this one slide. That's the entire time in my, that's the only time in my entire career that I use this delete thing. I don't know, maybe there's a use for it, but I prefer setting not to undefined maybe, but setting to null to show that this property exists, but it does not have a value. You would usually want all your objects to have the same all your objects of the same type. Say you have your person object here, you will want all of them to have all the same properties, even if they're not used for all of them. We will talk more about that later. Objects are interesting when it comes to let and const. Usually we say that if you don't want to change something, it should be a const, and if you want to change it at some point, it should be a let. And so far we've declared our object with let, but let's go and try something different. I want you to try this. Just take your existing code, just change from let to const, and then you can try these lines here. The idea is you declare the object as a const, and then you try to modify the age and console log the entire object. What happens? Try it out. It shouldn't take you long. So welcome back. You've tried this, changed your person to be defined as a const, and if you're like me, have everything else still there, then your output probably looks like this. You output the object just after changing it, and you can change the age. And you can even try it here. You can say person1.age++ again, and again, and again, and take a look at the person1. and it has the age of 33. One more that it wrote here actually. Interesting. So even though the object is defined as const, we can change the properties in it. So this one works fine. Okay, so before we think too much about it, let's go on to the next one. Try this one. Here I want you to create another object. Simply a copy of the first one, where you write your own name. You could also write your own age and your student, and then try setting person1 object to be this other object. So try it out. I'll come back when you're done. I guess you're done since you came back, so welcome back. If you have added another person and then tried this, you probably have the same result as I have, an error in the console. Invalid assignment to const person1. So it complains about person1 is a const, so you cannot set it to be something else. When you do this person1 equal person2, then you try to set person1 to be the same as person2. Can't do that. But what you can do is saying here we have person1 and we have person2. And you can actually say that person1's first name should be equal to person2's first name. And then if we take a look at person1, it has changed. So you cannot change the object itself, but you can change the properties. So this one does not work. The main thing to get from this is that you can change properties of an object. So we would almost always prefer our objects to be declared as consts, since we want the object to stay being itself and not suddenly be another object. We can still edit everything in it, add more properties, remove them and everything, even though the object itself is const. And this is the next thing we're going to talk about. Mutability. It's a weird word. It's mostly about referencing and copying objects. It's going to be a bit complex, so make sure that you have committed your changes, and maybe I should just do that here and go and commit here. Where are we? Here, git add object.html and object.js and git commit basic object stuff, and then go and serve yourself a nice cup of coffee or your favorite carbonated beverage and come back for talk about mutability. Welcome back. For mutability, I recommend that you have a new set of HTML and JavaScript files to try the exercises in, just to not get it too mixed up with everything we did before. And first, I want you to try this. Create a person object just like we did before and do it with const. We always want to use const for our objects from now on. Then create another object called person2 that is equal to person1. We can do this. We couldn't do it the other way around. We couldn't say person1 was equal to person2 because that's a const. But when we declare the const, we can set it to another one. And then I want you to try and change the first name of the other object so that that is called other Peter. And then console log the first object's first name and see, is that still Peter or has that changed to other Peter? And before you do it, before you try it, then answer to yourself, what do you expect it to be? Do you expect it to be other Peter or Peter? Try this out now and I'll wait while you do. So welcome back. Did you try it out? Did you guess? Did you guess correctly? No? Me neither. I was expecting person 1's first name here to stay Peter, and then person 2's first name to be other Peter. But when I look at it, it says other Peter. If I ask about person 1, that's called other Peter, and person 2 is called other Peter. And if I change something in person 1, I could also try to change the age is 123, and I take a look at person 2, that has also changed. So anything I do to person 1 also happens to person 2, and that is because, as the headline says, it's the same object. And another way of thinking of this is that the object is always the same, but the variables are different. The object being this one, with the first name Peter, and the age 29, and the student being false, that's the object. We don't give it a name, we just think of that. That's the object that floats around somewhere. The object, yeah. And then we have one variable, person 1, and another variable, person 2, and those two variables, they point to the object. They point to the same object. So the variable here isn't the object. Like this variable also isn't the object, but both of them are pointers or references, if you like, to the same object. We don't create a copy. So if we change something in person 1, it will also change in person 2 because the object is the same. Okay, let's try and introduce another variable. Here we still have the object, one variable, another variable, both of them pointing to the object. What if we say let person 3, now we just try to use let, just to confuse ourselves. Let person 3 be equal to person 1. Will person 3 then point to person 1? Try to answer this before waiting. Will it? Yes or no? And no, it won't. Person 3 will point to the same object as person 1 pointed to. I feel this is getting complex now, but always think when you create an object, you only have one object. Everything else is just references to that object until the next time you create a new one, like we did in the code, in the original code here. Here we have two different objects because we create them. But when we do this, then it's one object that is just goes by another name. You can also say that here this is the object, and we have two names for the object. It's called person and person 2. That's the names of these objects. We could create another one here. Let person 3 be equal to person 1. That's also just another name for the same object. Maybe if you try this out, then it will help. Take two persons here, and now I'm using let because I want to change the references. So we create one object for person 1, another one for person 2, and then we let person 3 be the same object as person 1. Start with this code. You can do it in the file you already have. Just change const to let, and then I want you to try these one at a time. First, you just say let person 3 equals person 1, like here. That shouldn't do anything. Then say, okay, what happens if you say person 3 first name changed? You know what? I'm going to show you what I mean. If you take here, let person 3 equal person 1, and then we say person 3 dot first name equal changed, and I also have to create the persons, let person 1, and there was another one, person 2, the other Peter has an age of 28, also not a student. And this is not part, so this is the code that I want to test. And then just say person 3, first name is changed. Now I want to try this code, like here, in the browser. I can't see anything, but I want to check what is person 1 and what is person 2 and what is person 3. So I just manually try this. You could also do it, I guess, by console logging them, but then it's a bit harder, because then you would say console log just person 1 and repeat that person 2, person 3. Then you wouldn't be able to see which one was which, so you would have to add an additional line before. Well, I guess you could do it like this. Then it would be automated. Person 1, person 2, person 3. Remember, you must do it like this on separate lines. If you write person 1 plus person 1, like this, where you put it inside the same console log, then you'll just get this object and not the full object definition here. So you can only get the clickable object if you only console log that object and nothing else. So this would also be a test for each line. And then of course you add the next line that it says here in the slideshow. It will be this one. And then console log everything again after that and see what happens and try it. And after this one and after this one. So try this out. It'll probably take some time. So just post the video and I'll be back afterwards. Okay, you tried it? And are you confused now? I would think so. I certainly am. I have all this here, so let me just walk through it and see if I can do it one step at a time. First off, I'm going to take this, all of everything here, and just, where is it? Toggle block comment around all of it. And then I'm going to take these lines that where I just console log something. And I'm going to console log everything as it is in the beginning. And then see what happens. So the first thing I see is person 1 is Peter, person 2 is other Peter, and person 3 is also Peter, because I set person 3 to be the same object as person 1. So this means that when I change person 3's first name, then it should change person 2 and person 3. So let's get rid of those. And then should see that person 1 and person 3 are the same, and their first name has been changed. When I save it, then I should see that now Peter is no longer Peter, but changed. And both of them are changed because they are the same object. Maybe it'll be easier to grasp this concept if we bring it out into the physical world. So I've got some pen and paper here, and let's just say here is our first object with first name Peter, and we have our variable, our person 1, and that variable here references this object. So person 1 is referencing this object. Then we have the other object here, the other Peter, and then we have person 2. and that's referencing this object. And then when we create our third variable, person3, that also references this object. So that we go, and no matter if we take a look at person1 or person3, it's this object. So that when we go and change, let me use a red one, that means that both person1 and person2 dot the first name would of course no longer be reference this property that has been changed. Let me use a thinner one here. Changed. That means that both person1 and person3 dot first name reference this property that is changed. So far so good. Let's go on to the next line. Now I set person3 to be person2. So I'm going to remove these outputs here. I'm going to remove the output every time I move them down. So when I set person3 to person2, that means that here, when I console log it, person1 should still be as it was before, the changed one. Person2 should still be the original one, the other Peter. And person3 will now also be that. That will also be the other Peter. Let's try that. Person1 is changed. Person2 and person3 are now the same object, the other Peter. And if we try that here in the physical world, that means that person3 is no longer referencing that object, but is now referencing the same object as person2 is referencing. So it's going this way. And now it means that these two variables reference this same object. So any changes to this object, whether it happens through person2 or person3, should change it for the other one as well. Okay. So let's try, once again, get rid of all the outputs. Make sure that we can see what we did here. Then we are going to change person2's first name. And since person2 and person3 are the same one, it should change both person2 and person3, but not person1. Person1 should still say changed as original, whereas 2 and 3 should say also changed. Let's try that. Yes, person1 is the changed one that was originally the Peter, and also changed was originally the other Peter, and both 2 and 3 are that one. And once again, in the physical world, when we take person2 here and change the first name to also changed, then it is the first name is also changed for person2 and person3 because they are still the same object. We could have written person3 dot first name equals also changed. It would have done the same. It's this object that changes. And finally, we'll try to set person1 to be person3, so person1 and 3 should now be the same. And since person2 and 3 were already the same, that means all of the persons should now be the same person. If we take a look, they are all the same. They are the also changed object. That would be this one that was originally person2. And then say, but what happened to the other one? Where is this object now? And it's actually gone. Since no one is referencing it, none of the variables that we have are pointing to this object. So the JavaScript engine decides that, well, that's object that's no longer used, so it will be deleted. Once again, in the physical world, we ask person1 to no longer point to this object, but to point to the same one that person3 is pointing to. So that one there. So all three variables are referencing or pointing to this same object, and nobody's pointing to this one. So that is unused, and that is JavaScript then goes, or the JavaScript engine then goes and simply removes it and throws it out. That's, by the way, that's something called a garbage collection. We don't really need to know that, but we need to know that it's gone. We cannot get it back when we no longer reference it from any of our variables. So you might ask, why is this important? Why do I need to know that an object exists and variables point to it or reference it? Well, the first thing is that you need to know that when you change something in an object, you don't change a new thing, you change the original object. So once we get to more complicated programs where objects are sent around between functions, it's the same object. So if one function changes it, it will affect all the others. Another thing is when going into comparing objects. There's a problem with comparing objects. Sometimes we would like to see if two objects are similar, if they are equal, if they have the same properties. But JavaScript is more interested in, are they the same object? So let's go and try this. I want you to type this bit of code in. Let's just create a new JavaScript and HTML file. Let's call it compare, where you have student1 and student2. Student1 is an object, first name Harry, last name Potter. Student2 is a variable that is equal to student1. And then I ask you, what happens if we compare these objects? If we compare them like this, if student1 equals student2, will it console log they are the same, or console log that they are not? Try this code and then come back once you have. So I guess you have tried this code, entered it here, and gotten the result that they are the same. Of course they are the same, you just set it to be the same. Student2 is student1, it's the same object. So let's get on to the next thing. I want you to try these two objects. Your student1 object is the same as before, but then replace your const student1 equals student2, get rid of that, and instead have this student2 here, and then run the compare. Are they the same object? And first, before you run the code, try to guess, will it say they are the same or will it say they are not? And don't worry, nobody can hear your guess. So did you guess correctly? Have this code, the two student objects, are they the same or not? And they are not. But they look kind of same-ish, don't they? But if we go here and think they are two different objects. This is the first object with first name Harry and last name Potter, and the student1 variable points to that one. Here's another object with first name Harry and last name Potter, and the student2 points to that. So the two variables point to two different objects, so it's not the same object, even though they are completely identical. So think of them as maybe as twins. It's not the same person, but they look a lot alike. What then if we change one of them? If we change student1 here, will that also change student2? So just as before, we just want to change first name of student1 and then console log both of them. What will happen then? And why or why not? Try this. Modifying one of the objects and console logging both of them like this, just ignore that part here, but changing this and console logging them, that should show us that both objects are very different. Student1 here is Potty Potter and student2 is Harry Potter. So why are they different? Why didn't it do like the last time where we changed other people to changed and so on? And of course, it's not the same object. Student 1 and student 2, they have nothing to do with each other. Okay, so let's try making them more similar. Try this before the if statement. Say student 1 first name is equal to student 2 first name, and student 1 last name is equal to student 2 last name. This should make them completely identical. Absolutely certain that they are the same. So what happens when you compare them now? Try it out and then come right back. You have tried it out? I have, and I just realized that I need to get rid of this test that I did to change one of them. I want them to be the exact same. I create them, they look identical. I set the properties, though they are certainly identical, and then I compare them. Are they the same? And let's just make sure that we have saved. Reload. No, they are not the same. Even though we look at student 1, object, first name, Harry, last name, Potter. That's all it has. And student 2, object, first name, last name, Potter. And there's some prototype stuff going on here. But that's just empty. That's just default functions that are built into JavaScript. So they look the same. They're very much alike. But when we compare them, they are not the same. Because, of course, it's not the same object. So that means that when we compare things, we can try, by the way, to does it make any change if we have 3 equal signs here? And no, it doesn't. No matter if we compare them with 2 or 3 equal signs, we always have to answer these questions here. Are they similar? Are the objects similar? Well, it doesn't really matter. Comparison will say false, so it will go, they are not. If they are like have the same properties, no, false, they are not. Are they identical? Exact same properties, same values for other properties? No, they are not. Are they the same object? And that returns true. So comparing objects here doesn't compare objects. It just tells us, are these 2 variables pointing to the same object? And it's really, really rare that we actually need to know this. So this is an annoying feature of JavaScript and objects. And we have to find different ways of comparing objects, especially when we have a lot of them. That will be the topic for a later presentation. But in summary, for objects, they can have properties with values. And those values can be any kind of data type, even other objects. We can add and delete properties even when an object is const. We can read and write the value, and we can change them as much as we want to. Still, even if it's const. As I say here, they can be changed even if they are const. All variables that are set equal to an object will point to the exact same object, meaning that we can change the properties via any variable. If we have our object 1 and we set object 2 equals to object 1, it doesn't matter if we say object 1 or object 2 when we want to change some of the properties. They are just references. We can compare objects with double equal or triple equal. We can only check if they are pointing to the exact same object. So if they were created with a variable that was set equal to it. Otherwise, this doesn't make sense in any other case. And objects are just plain weird, especially when it comes to variables and references and so on. But I just want you to take this from this presentation, this one thing. You almost always work on the same object anywhere in your code. unless you explicitly code it to create copies, you will have the original object and you can change it even if it's declared as a const. Just remember that one thing. Hope to see you again soon.